Hello everyone. Today we are going to discuss next part of the ionization energy. Generally, yesterday I have forgot to mention few points, and also we are going to talk about the importance of this ionization energy. So in this case, so generally the ionization energy is the energy which is given to a neutral gaseous atom to remove that electron. Since energy is given to that particular element, so it is called as what? Endothermic, because energy is given to that element. So energy is absorbed by that element. So that's why it is called endothermic. And generally this delta H is written as positive because the element absorbs the energy. Next point, generally this ionization energy for cations is positive because we have to give the energy because of more nuclear force of attraction. So it is what positive. For anions, so ionization energy will be lesser, or generally we can write it is negative. That means energy is going to be released. We cannot be given. Okay. Next, while discussing few trends, especially I forgot to mention yesterday, like the trends, what is going to happen for these coinase metals? Coinase metal which belongs to 3D or the transition elements. So in this case, so what is going to happen to the trend of these coinase metals? So what about their ionization energies? Generally, if you observe, so how they will be like copper, then you can write silver, then it is what gold. So it is what 3D series, it is 4D series, and it is 5D series. So in this case, while going down the group, we should know that their ionization energy values are going to decrease. But when it comes to this, so what is going to happen? When it comes to the gold, when it comes to the gold, it is experiencing what? Lanthanoid contraction. As yesterday we discussed what is lanthanoid contraction. So this lanthanoid contraction of this gold. So due to poor screening effect, what is going to happen? Its atomic release is decreasing, as well as it needs more energy for removing electron from this. So ionization energy will be maximum for whom? This is what for gold. And next will be copper, then it will be silver. So in this case, what we can write, the ionization energy for gold will be maximum, then copper, then silver. Why it is called coinage metals? From this, in ancient days, they were used to make coins from this copper, gold, and silver. So out of this, gold will have more ionization energy because of lanthanide contraction, size is decreasing. So we have to apply more energy. And when it comes to this 4D and 5D series, especially 4D series, so in this case of palladium and silver, whose will be the more ionization energy, as we yesterday itself discussed. So the while discussing or while predicting the ionization energies of different elements, so we have to consider the electronic configuration. So we have to see whether that particular element for whom we are going to find out the ionization energy. So we have to check whether that element's electronic configuration is stable electronic configuration or not. That means how will you identify the stability? As I told you, that is what you have to check their what called their half filled or fully filled. In this case of S, if two electrons are there, it is fully filled. For P, if six electrons are present in p orbital, so they are fully filled. If three are there, that means they are half filled. So if for d orbitals, if they contain 10 electrons, so they will have more what's called that's more stable or fully filled, and if they contain 5, then they are called as half filled. Similarly for f block elements or f orbitals, 14 electrons makes them fully filled and 7 electrons makes them half filled. So in this case, you will see for palladium, you will see 4d10 is the outermost electronic configuration. Since they are what? Fully filled. This is what? Fully filled. Since they are fully filled, and when it comes to silver, it is what? 5s1. So we can easily remove electron from the 5s1, but it is highly difficult to remove electron from 4d because 4d10 because it's fully filled, and fully filled means it's highly stable. So ionization energy for palladium will be more. Similarly, when you see for cadmium and indium, in the case of cadmium, it is what? 5s2, its outermost electronic configuration. So because of that, it is what? Fully filled again. It is fully filled. Since fully filled, here obviously needs more ionization energy as compared to indium, because for indium, just one electron we have to remove. So in this case, cadmium will have more ionization energy as compared to indium. When it comes to mercury and thallium, you see, in the case of mercury, what is the 6s2? It is what? Fully filled. When it comes to thallium, it is what? 6p1. It is not fully filled or half filled. So it's not much stable. So this is fully filled, so it's more stable. So it will have more ionization energy as compared to this thallium. And also one more point, while writing in the group, especially for transition elements, we are going to see what's called lanthanoid contraction. Because of that lanthanoid contraction, size contracting, so that ionization energy is increasing. But in the case of scandium, yttrium, and lanthanum, so this is not going to be absorbed. So as usual, ionization energy decreases while going down the group. Then you should say that lanthanoid contraction, where number of times you are studying that lanthanoid contraction. But when it comes to lanthanum, the element whose atomic number is what? 57. So in this case of lanthanum, can we observe, this is what lanthanum, can we observe lanthanol contraction? No. What is that? We don't observe lanthanoid contraction. We don't observe lanthanoid contraction in the case of lanthanum, because after lanthanum only the electrons are filling into 4f subshell or 4f orbital. So because of that reason, so poor screening effect will not be shown in the case of lanthanum, so that they don't consider or they don't observe what is that lanthanoid contraction for lanthanum. So the elements which are coming after 72, generally mostly we are going to see what is that? They are going to experience lanthanol contraction. So the size decreases, so ionization energy values are going to increase. So this is what the points I have just forgot to mention in yesterday's class, in the last class. So now we are going to discuss what is that importance of this ionization energy. So in this importance of ionization energy, we have to see very much important point, that is low ionization energy. Low ionization energy means the metal in which, so we are providing only less energy to remove that electron. When it is possible, when it is having more number of shells and experiencing more screening effect. So because of that reason, what is going to happen, you can see, so we need low ionization energy, less energy to remove that electron. When you are giving less energy to remove that electron, that means it is called more metallic. When a particular element is having low ionization energy, then that particular element is called as what? Metallic in nature. Why highly metallic? Why? Because metal has the tendency to lose electrons. So those metal who can easily lose electrons, they can be called as highly metallic. First point. Second point, low ionization energy also will talk about electropositive character. What is electropositive character? Again, same thing. When an element or metal loses electron, they can immediately become what? Electropositive. Regarding my point, and they're forming cation. Cation means electropositive. So who can easily become more, who can be called as more electropositive? That means the particular element which is going to lose electrons very easily. When it can lose electrons very easily, when it is going to have low ionization energy. First point. Next, very much important property, that is called reducing agent. As we know, especially these alkali metals are called as very strong reducing agents. Like we can say lithium is a very good strong reducing agent. So that the why it is, we'll study in group 1 elements or S block elements. But here, why they are called as reducing agent? Reducing agent means they are helping in the reduction of other substances. How they are helping in the reduction of other substances? By releasing electron. That means when a substance is helping in the reduction means they themselves has to undergo oxidation. So oxidation means losing electrons. So those who could able to lose electrons easily, so they are called as what? They become very easily oxidized, and they are called as better or best reducing agents. So when can an element easily loses electron? When they have low ionization energy. So those elements which has low ionization energy, they can act as better reducing agents. But exception is what? Lithium. So why? So we will discuss later why it is, and because of its high hydration energy. So in S block elements we'll discuss. And also we know that when it is more metallic, and their oxides and their hydroxides are also will show basic nature. Is it clear? When the element is having low ionization energy, so they will have more basic nature. Second point, so when the element is having low ionization energy, they are going to form ionic compounds. Ionic compounds, how they can going to form? By forming ionic bonds. How the ionic bond is going to form? It is between metal and non-metals. So they have to transfer electrons from metal to non-metal. So how the transfer of electrons will take place? When the element metal has to lose electrons easily, so then only the transfer of electron takes place. When a metal can lose easily loses electron, when they are having low ionization energy, so that those metal who is having low ionization energy, they has the easy tendency to form ionic compounds. And next one is they are going to exhibit photoelectric effect. You know that photoelectric effect means when metal is struck with high energy light, what is going to happen? The photons are going to, the electrons are going to be released. So when a metal is going to release electrons, when it is having low ionization energy. So this is what the importance, and also very much important point here. So which ion is stable, which cation is stable? Since ionization energy means we have to remove electrons. So we should understand here how many electrons has to be removed, and if you remove one, two, is it our wish? No. So when the energy is released, so according to energy, so we have to see which element or which ion, which cation is stable. So when successive ionization energy difference means, that means if you have removed one electron, so it is called first ionization energy. If you remove second electron, it is called second ionization energy. If you remove third electron, it is called third ionization energy. So we have to check, as we are removing electrons, it's forming 1 plus 2 plus 3 plus, these are what? Cations are forming. So which cation is stable? So for element, for metal, how many electrons has to be removed? So that can be understood through the energy. So how much of energy which is necessary? Are you getting my point? So in successive ionization energy differences, if it is less than or equal to 1450 kilojoule per moles. See, the energies can be measured in the form of electron volts or kilojoule per mole. Then when successive ionization energy difference is less than 1450 kilojoules, then the higher oxidation state is stable. Remember, higher oxidation state is stable. What is the higher oxidation state? What is lower oxidation state? With the examples I will tell you in below. In successive ionization energy, if it is getting more than 1450 kilojoules, then its lower oxidation state is stable, is considered as stable. How? By taking example of lithium and calcium, we can understand. Lithium, if it loses one electron, so that means to bring out one electron from the lithium, we have to apply the energy. What is that energy? First ionization energy, that is 520 kilojoule per moles of energy is getting released. And if you want to remove one more electron from this unipositive cation, again you have to apply more energy because it is already unipositive ion. So that, what is the second ionization energy that we are going to see? That is 7300 kilojoule per moles. So the difference, what I told you, successive ionization energy difference. When you see the successive ionization energy difference, IE2 minus IE1, how much you are getting? 6780 kilojoule per mole, which is more than 1450 kilojoules. When the successive ionization energy difference is more than 1450 kilojoule per mole, then lower oxidation state is stable. Lower oxidation state means what? When it lost one electron, it is what? Plus 1. And when it lost another electron, it called become plus 2. These plus 1 and plus 2 are called their oxidation states. So which oxidation state is more stable? Lower oxidation state. Lower oxidation state means plus 1. So that's why Li plus is stable. Li plus is stable. Hope you are getting my point. Next, for calcium, if you see, if you remove one electron from the calcium, so it is becoming Ca plus, unipositive ion, and its first ionization energy is 590 kilojoule per moles. If you remove one more electron from the calcium, Ca plus, so that what is going to happen? It will become Ca2 plus. What is its ionization energy? 1145 kilojoules per mole energy is released. Now you will see the difference in the successive ionization energies. So 1145 minus 590, how much we are getting? 555 kilojoules of moles. So 555 means which is less than 1450 kilojoules. When it is less than 1450 kilojoules means what we can say? Higher oxidation state is stable. Higher oxidation state. So higher oxidation state means here it is Ca plus, it is plus 1 is its lower oxidation state. Plus 2 means it is what? Higher oxidation state. So when its energy is less, so which one can be stable? Higher oxidation state is stable, that is Ca2 plus is stable. So this is what we have understood from complete ionization energy. And so this video might be short, and next video we are going to see the next periodic property, that is what electron affinity or electron gain enthalpy, and what is the difference, and as well also we'll discuss about electronegativity in the same uh, topic, and also different properties. And after that, after completing the periodic properties, so we are going to practice the questions, especially previous year questions, which are based on what? Classification of elements, especially on periodic properties, like for both for NEET as well as for JEE mains and advanced. So these questions will be solved. Okay, thank you.